Let's listen to the last video. So in this video, we will talk about the solvings of the inequality, and also we will talk about the absolute value, how to solve for the absolute value. But before that, let me give you the 6 rules for the inequality first. For example, you have the A, B, and C, which are the real number, and then you have 6 rules to apply for the real number or for the rule or the inequality. The first rule is that when A is less than B, and then if you want to add the C to both number A and B, then you will have A plus C is less than B plus C. And also the same as when you want to subtract C from both A and B, you will have A minus C is less than B minus C. And rule number 2 says that when A is less than B and C is greater than 0, and then when you multiply C to both A and B, you will have AC is less than BC. A is still less than B. But in the rule number 4 here, when you have A less than B, and in this case, if C is lesser than 0, which means that the value of C is the negative value, then BC will be lesser than AC this times. Okay? And the special case for the rule number 4 is that when you have A less than B, that's also equivalent to minus B is less than minus A, the reverse process. And number 5, when A is greater than 0, then 1 divided by A must also be greater than 0 for the inverse. And then number 6, if A is less than B, then 1 divided by B is less than 1 divided by A. Okay? For example, here in this case, if you have 2 less than 5, right, and if you apply the special case here, it will become minus B, which is minus 5 is less than minus A here, where A is 2. So you will have 5 is less than minus 2, or in other words, 2 is much greater than minus 5. Okay, and the next ones, you can also apply rule number 6 to this one as well. So when you have 2 less than 5, so let's see in this case, when 2 is becomes A and 5 is becomes B, then it will be implied to 1 divided by B, where B is 5, and 1 divided by 5 is much lesser than 1 divided by A, where A in this case is 2. Therefore, 1 divided by 2 is much greater than 1 divided by 5. So in this case, you apply rule number 6, and in this case, you apply special case in rule number 4. Okay, so that's our 6th rule for the inequality. Right, next example. I ask you to solve for the following inequality and show the solution sets on the real lines. The first one, in part A, 2x minus 1 less than x plus 3. So you have to solve for the value of x, and then after you know the value of x, then you have to draw the solution sets on your real line. For example, here in this case, you will start with 2x less than x plus 3 plus 1. So basically, you move minus 1 to that side, and then you add 3 plus 1, it becomes 4. So you want to look for the value of x, then you move this x to that side. Therefore, it becomes 2x minus x, which is equivalent to this x and less than 4. So you know that the value of x here must be less than 4, but not 4. Then your solution set is an open interval, since you don't have to include the value of 4 in the set. It must be less than 4, so which means that it must support this is number 4, right? This is the open circle for the 4, which does not include the value of 4. Then x must be less than 4, so it must be this value, and then you have to draw the arrow toward the left hand side, okay, which means that toward the negative infinity. Then negative infinity obviously does not include that in the set, and 4 as well. So this is how you can write for the notations of that solutions, okay. And this is when you draw the line, okay. This is when you draw the line. You can see that you have the open circle at the point 4, and then you can draw the line toward the negative infinity, which means that x can be 1, x can be 0, x can be -1, -2, and so on until the minus infinity, but not 4 or the number that is greater than 4. Next, when you have minus x by 3 less than 2x plus 1. So basically you can move 1 by 3 here to another side to be multiplied by 2x plus 1, and that becomes 3 multiplied by 2, you got 6x, and 3 plus 1, you got 3. So then you got minus x less than 6x plus 3. And next, if you want to move minus x to the right side of the equations, so on the left side you will have left with 0, and that 0 is less than 6x plus x, and this x is moved for the left side of the equations, and then plus 3 remain the same. And 6x plus 1x becomes 7x plus 3. So we want to look for the value of x. Then in this case, we know that x must be greater than minus 3 by 7. Minus 3 by 7, which means that you have to go toward the positive infinity, and the value of minus 3 by 7 does not include that in the set, so it must be the open circle point at the point minus 3 by 7, and then you go toward that side. Okay, so this is how you can specify the notations for that, and this is the set notations that you can draw on the real line. Okay, you can take a look that this one is the open circle at the point minus 3 by 7, and then go toward the positive infinity here in this case, right? Next one, the last example. For example, you have 6 divided by x minus 1, and that is greater than or equivalent to 5. So in this case, you will have to find the value of x first, and after that you have to specify the solution set for that interval. So just like the previous 2 example, you move x minus 1 to the right hand side of the equations to be multiplied with the 5, and then you will have 6 that is greater than or equivalent to 5x minus 5, and then you move the number minus 5 to the left side of the equations, then it will become plus with 6. Therefore you get 11, which is greater than 5x. Then you move 5 to be divided by 11, then the value of x must be less than or equivalent to 11 by 5. So that is the value for the x. So these terms 11 by 5 will be included in the interval, or will be included in the sets, okay? And then the value of x is less than or equivalent to 11 by 5. So if you just take a look at this step, you will see that, okay, of course, this is the real line, and that is the positive infinity, and that is the negative infinity, and that is about 0. Okay, so that it may be about like 11 by 5. So 11 by 5 is included. Then we draw the cross circle here, and then the value of x must be lesser than or equivalent. Therefore, you have to go towards this side, okay, toward the right side of the real line. But when you have to specify the notations, it can be minus infinity, comma 11 by 5, and then you put the square parenthesis to indicate that 11 by 5 is included in the set. Okay, so that is how we do that. But in this case, the solutions is not the correct one. Why? Because if you take a look in this sign here, you can see that 6 divided by x minus 1. Okay, so if the value of x is lesser or equal to 11 by 5, it must include the value of 1, right? It must include the value of 1. But the value of 1 here cannot be the value of x, since if you apply the value of 1 here, it will become 6 divided by 1 minus 1, which is equal to 6 divided by 0, so that is undefined. So we don't want 1 to be the value of the x. Then we have to focus on the value of 11 by 5 until the value of 1, where the value of 1 will not be included in the set. Okay, therefore we have to focus from 1 to 11 by 5, but the value of 11 by 5 need to be included. Then we have to use the square parenthesis. But for the value of 1 here, we have to use the circle parenthesis to indicate that 1 should not be the one of the value for the x, because it makes undefined solutions for that. Okay. And that is how we find out for the solutions of the x, and we draw the real line. Okay. Therefore, the correct real line in this case should be starting from 11 by 5 and then go until the value of 1. But the value of 1 need to be with the open circle point, okay, to indicate that 1 does not include that in the set. Right, next is about the absolute value. The absolute value of a number x denoted by the absolute sign here, and the absolute value of the x can be defined into different solutions. The first one is for the positive, and the next one is for the negative. So it will be the negative if and only if the value of the x becomes lesser than 0, and positive if and only if the x is greater than or equal to 0. So basically, the definitions of absolute value is to find the distance between the two numbers. For example, in this case, we have the absolute number between the x and the y, or x minus y, and then you have the absolute, which means that you can find the distance between x and the y. Okay, it gives the distance between 2 points on the number line. Like for example, here you have minus 5 to 0, and from 0 to 3. So you can see that in this case, if you subtract 0 by 5, okay, you will have, if you subtract 0 and minus 5, you will have the absolute of 5, which is 5, which means that the distance between 0 and minus 5 is about 5 points. And also the distance between 0 and 3 is also about 3 points as well. And in this case, 1 and 4. So the magnitude of the x minus y, or 1 minus 4, or 4 minus 1, the solutions will be the same. For example, if you start with the 4 first and then subtract by 1, you will end up with magnitude of 3. But if you start with 1 first minus 4, you will end up with minus 3. So magnitude of minus 3 equivalent to magnitude of 3, and magnitude of 3 becomes 3. So which means that the distance between the value of 1 and the value of 4 is about 3 points. Okay, so that is the definitions of the absolute value to find the distance between the two numbers. Example 2, finding absolute value. The first one, the absolute of positive 3 is equivalent to 3. Absolute of 0 is basically equivalent to 0. Absolute of minus 5 equivalent to absolute of 5, and that's also equivalent to 5. The absolute of minus of the absolute A is also equivalent to absolute of A, and absolute of A is also equivalent to A. Okay, And next one, is it important to remember that the square root of the a square is equivalent to the absolute of a, not just the a. Okay, why is that? Because in this case, for example, if you like the square root of 3 square, which is equivalent to square root of 9, and square root of 9 is equivalent to plus minus 3. Okay, so when you line in this case, you have to specify that a is inside the absolute sign, or you can either line it in positive and negative value for that value of a, right? And next, let's talk about the property or the absolute value. In the property number 1, the absolute of minus a is equivalent to the absolute of positive a. The absolute of ab is equivalent to the absolute of a multiplied with the absolute of the b. That is the product between the two absolute values. And next, the quotients between the two absolute. The absolute of a divided by b is equivalent to absolute of a divided by absolute of b. And the last ones, the triangle inequality. So you have the absolute of a plus b, which is less than or equivalent to absolute of a plus absolute of b. So that is the for the first 4 property of the absolute value. And next we will take a look in the example. Notice that the magnitude of minus a here is not equivalent to minus of the absolute a, right? For example, in this case that I show you, magnitude of minus 3 should not be equivalent to minus of the magnitude 3. Okay, why is that? Because the magnitude or the absolute of minus 3 is equivalent to plus 3, and that is also equivalent to 3. Okay, and this one is not equivalent to minus 3. 3 is not equivalent to minus 3, right? Next, absolute value bar in the expressions like the absolute of minus 3 plus 5. So when you want to work out on the absolute here, the absolute value here, you can think of the parentheses. So for example, you have parentheses of minus 3 plus 5 here. Okay, and then you also have to multiply that maybe by 1. So you first thing you have to perform the mathematical process inside the parentheses first, and then you continue multiply that by 1. So in this case, it will be 2 multiplied by 1. So you perform the system inside the parentheses first, and then continue multiplying by 1 at the last step. And that apply to the state or the absolute sign. We do the arithmetics inside the absolute sign first before we taking the absolute value. Okay, you have to add between minus 3 and 5 first, and then after you get the result, you perform or you take that absolute value of that result. Okay, at the final step. Right, so next we will give some example to support the rule number 4, which is the triangle inequality. When you have a plus b, and then that will be less than or equivalent to magnitude of a plus the magnitude of b. So we will see that together. Right. In the example 3, I will give you the example of the triangle inequality to support the rule number 4 for the absolute inequality. So in this case, when you have the magnitude or when you have the absolute of minus 3 plus 5, that will be equivalent to magnitude of 2, and magnitude of 2 is equivalent to 2. Okay, and that is also less than or equivalent to magnitude of magnitude of minus 3 plus the magnitude of 5, and that is equivalent to 8. Okay, so in this case, if you could remember from the rule number 4 of the absolute inequality, you will have magnitude of a plus b is less than or equivalent to magnitude of a plus the magnitude of b. It can be equivalent or it can be lesser than. Okay, so in this case, you have minus 3 plus 5. So minus 3 plus 5, you will have you will end up with the magnitude of 2, and the magnitude of 2 is equivalent to 2 on the left hand side, okay, of the equations. And then the right hand side of the equation here, we have the magnitude of a. So a in this case is the minus 3 plus the magnitude of b. So b in this case is 5. So magnitude of minus 3 become 3 plus with the 5, and thus becomes 8. So this one is correct, okay, if you apply the rule number 4 here. So 2, okay, is less than 8, so this is correct, right? And next one, you have 3 plus 5 equivalent to magnitude of 8, and that's also equivalent to 3 plus 5. Okay, so that's fine. And the last one that I want to emphasize, suppose you have the magnitude of minus 3 minus 5, and that should be less than or equivalent to the magnitude of minus 3. Adding up with the magnitude of minus 5, so let's continue solving for the terms on the left side first. So that will be minus 3 minus 5, you will get minus 8. So magnitude of minus 8 is become magnitude of 8, and magnitude of 8 is becomes 8. And that side as well, so you get magnitude of 3 plus magnitude of 5. So magnitude of 3 plus magnitude of 5, you will get magnitude of 8, and that's become 8. So in this case, 8 is equivalent to 8. Okay, so you can see that in this case, if we apply the triangle inequality or the rule number 4 of the absolute inequality, we will get either the less than solutions or the equivalent solutions. Okay, and then you can find the distance between one value and another value by using the absolute sign, right? And the last 5 applications or last 5 rule for the absolute, okay, is that in the rule number 5, the absolute of x is equivalent to a if and only if x is equivalent to plus minus a. The magnitude of x is less than a if and only if minus a less than x and x is less than a. Magnitude of x is greater than a if and only if x is greater than a or x is less than minus a. And magnitude of x is less than or equivalent to a if and only if the x is less than or equivalent to a or x is greater than or equivalent to minus a. And the last ones, magnitude of x is greater than or equivalent to a if and only if x is greater than a or x is greater than x is less than or greater or equivalent to minus a. So that's it, the 5 difference rule for the absolute value and the interval. Okay, so let's see the example here. So in this example, I ask you to solve for the equations with the absolute value. So you have to solve the equations, the absolute of 2x minus 3 equivalent to 7. So in this case, you can okay, if you go back to the previous slide here, you can apply rule number 5, which is the absolute of the x is equivalent to plus minus a. Therefore, in this case, you will have the magnitude of 2x minus 3 equivalent to 7 for one value, and the magnitude of 2x minus 3 equivalent to minus 7 for another value, and then you find the solutions for that. Okay, so therefore in this case you will have 2x minus 3 equivalent to 7 and 2x minus 3 equivalent to minus 7 here in this case. So 2x equivalent to 7 plus 3. Therefore, x becomes 10 divided by 2, or it is 5. And then this one, it will become minus 7 plus 3. So you will have minus 7 plus 3, which is minus 4. Okay, therefore your x would be minus 2. So you have x equivalent to minus 2 and x equivalent to 5. So you have two different solutions for these equations. Therefore, you can just answer that the solutions of the 2x minus 3 equivalent to 7 are x equivalent to 5 and x equivalent to minus 2. Okay, next example. For example, you are asked to solve for the inequality of the absolute of 5 minus 2 by x, and that is less than 1. So if you could remember from the rule, okay, number 6 here will be applied for that example, right? So in this case, you will have 5 divided by, minus 2 divided by x is less than 1 and also less than minus 1. Okay, if you apply the rule number 6 here of the absolute value. So if you apply the rule of absolute value number 6 here, in this case, you will get 1 is less than 1 and another 1 is greater than minus 1. Okay, so then in this size, if you want to remove the plus 5 here, you have to subtract 5 on both sides. Okay, and also in the middle term as well. And then in the middle term, you will have left with minus 2 divided by x, and then 1 minus 5 minus 1 minus 5 it becomes minus 6. 1 minus 5 it becomes minus 4. Okay, and next, so that is the interval after you subtract both terms or both sides by 5, okay, to remove the number 5 in the middle terms. And then you have to multiply by minus 1 by 2, okay, to remove this minus 2, right? So you have to do that on this side and this side as well. Then you will get 3 less than 1 by x, because you multiply that with the minus sign, so the less than sign will be changed. Okay, the greater than sign will also be changed as well. Therefore, you have 3 less than 1 by x, and that 1 by x is greater than 2. Okay, it's still reciprocal for the x. Then you have to apply the reciprocal process in that case, and not just only the number here. Okay, from 3 it will become 1 by 3, from 2 it will become 1 by 2, and that side as well you have to apply the reciprocal for 1 by x, which is equivalent to x. Okay, therefore we know that the value or the interval for the x is lie between 1 by 3 and 1 by 2. Okay, and next example, so you are asked for 2x minus 3, and then you put the absolute sign, and that is less than or equivalent to 1. Okay, right. So in this example, if you apply the property number 8 here, you will have the magnitude of that 2x minus 3. One is less than or equivalent to 1, and another is greater than or equivalent to 1. So you add the number 3 on the left side, on the right side, and also on the middle term in order to remove the value of minus 3. Therefore, minus 1 plus 3 is become 2. 1 plus 3 is become 4 in this case, and then 2x remain the same. Okay, and then you need to look for the value of x. Then we have to divide by 2 for every side and also at the middle term as well. Therefore, 2 divided by 2 you get 1, and 2x by 2 you get x, and 4 by 2 you get 2. Therefore the value of the interval for the x is lie between 1 and 2. The value of 1 and 2 are included in the interval as well. Then you can just use the closed interval notation to indicate that the value of x here will be lies between 1 and 2, and the value of 1 and 2 can be one of the solutions for the x as well. Okay, so that is how you find the value of the x, or how you solve the inequality, and then you use that solutions to find out for the interval, and then you write the solutions in terms of the notations, or in this case you can even draw the real lines for the solutions. Therefore, if you want to draw the real line, in this case it will be 1 and 2, and 1 and 2 are also included in the set. Therefore, this is the real line for this example. Okay, right, that is how we perform the real line solutions. And then the last example, suppose you have to find the absolute of 2x minus 3, and that 2x minus 3 is greater than or equaling to 1. Then you will have to find the solutions for the value of the x. So in this case, you will have two different solutions for the x if you apply the property number 9. So in the property number 9, it said that the value of 2x minus 3 is greater than or equaling to 1. Okay, and it's also must be lesser than or equivalent to minus 1. So you will have two solutions for the x. Okay, I will go back to the property number 9 for you, and then you can have a look to that. So you will have the value of x. One is greater than or equivalent to a, and the another one is the value of x is less than or equivalent to minus a. Okay, right. So that is how we have two different solutions for the x. So one solution here is greater than or equivalent to 2, and another one is less than or equivalent to 1. So for this case, we know that x must be equivalent or greater than 2. So if we draw the line here, so we have the value of 2 here, so we have to use the closed circle here, and then the solution will be line toward the positive infinity. Therefore, it must be the square parenthesis of 2, and then comma with the positive infinity. So you have the closed parenthesis, or you have the circular parenthesis for the positive infinity, and this one as well. So in this case, it starts from the value of 1 and then go towards the negative infinity. Therefore, you can just write the open parenthesis or the circular parenthesis for the minus infinity, and then comma with the value of 1, and 1 here you have to end with the square parenthesis since 1 is included in the set. So that is how we find out the solutions for the inequality for the x, and then you draw the real line. Therefore, in this case, you will have two different solution sets for the x. One is greater than or equivalent to 2, and next is less than or equivalent to 1. Okay, so that is all for today's lecture. So let's meet again on the next video lessons, and I hope you have a clear pictures of the set notations of the real lines and also the subsets. And the last one is about solving the inequality, especially the inequality of the absolute value. Okay, goodbye for now, and let's see again with the next video lesson. Bye bye.